Our relative frequency is going to be, oh, sorry, today's going to be, we're talking about frequency tables, okay? And frequency is how often something happens. A frequency table, and then we're also going to make relative frequency. So this one would be a frequency table right here. It tells you, for example, someone says if your team won 9 games from a total of 12 games played, then the frequency of winning is 9, but the relative frequency would be 75% because you got to do 9 out of 12. So that's the difference between a frequency question versus a relative frequency question. Please stop, Jamar. Thank you. All right, a two-way table. This is what a two-way table is, and you should know how to read this. So, for example, how many ninth graders prefer math? 10. How many ninth graders prefer English? 12. How many ninth graders in total? 22. Okay. Please start filling in the table. And the same thing for the 10th graders. 12 prefer math, 11 English, and you have a total of 23 10th graders. All right. We have 19 11th graders. 11 prefer math, 8 prefer English. And this one is half and half. 8 prefer math, 8 prefer English of the seniors. Okay. If I want to know the total number of students, all I need to do is I need to add these numbers right here. The 22 plus the 23, the 19, and the 16. And that gives me 80 students in total in all the grades. Now, if I just want to know the students that prefer math, then I would have to add up this top row, the 10, the 12, 11, and 8, which gives me 41. And if I just want to know the ones that like English, it would be, you can also just do 80 subtract 41, 39. All right, and the 41 plus the 39 also gives you the 80. So a frequency table is pretty much a closed system, okay? And you can ask questions such as, how many students are in 11th grade? How many students in the 9th grade and also prefer math? Right, so you're looking at the 9th graders prefer math here, so it's only 10. How many students prefer English and are in the 12th grade? Yeah, so it'd be this 8. And how many students in total? We already calculated that, it's 80. And like I said, the way that the totals work, um, you have to find which one you can fill in first. So for example, this one we can't do because we have 2 blanks. This one we cannot do because we have 3 blanks. So you need to be ingenious and figure out which ones we can do. We can do the total. See? Just add those 2 numbers and how much do we get? All right, correct. It's 221. All right, now that we have the 221, you can backwards calculate the missing number over here. All right, so take your total 221 and subtract those 3 to get the number that goes there. Please go ahead and play with your calculator and get the numbers because you're going to be on your own. This was done in 6th grade and in 8th grade, knowing how to manipulate and how to use them. I'm going to be focusing on the questions. 80? All right, now that we have the 80, you can backwards calculate this one. 35? Okay. Oh, we can backwards calculate the one that's missing here. Give everybody an opportunity before we shout out the answer. Okay. So it would be the 92 subtracting those 3 numbers, and what do you get? Is it correct? I'm not looking at an answer sheet. Okay. This one is? And this one? Can you guys be more careful when giving the answers because I get all of those numbers at the same time. All right, so now, very simple. How many students are there total? Okay. How many ninth grade boys walk to school? Mhm. All right, on your own, read C and read D and get your answers. Okay, so how many ninth grade girls ride the bike? And how many males took the survey? Okay, so you have the basic skills of being able to read the graphs. Okay, so now we're going to take it to the next step and we're going to talk about relative frequencies. So this is the percent. This is the decimal or the percent. Okay, please write that down. Frequency, we're dealing with the total numbers, like in the previous two tables. But if it's relative frequency, we're dealing with a decimal with a percent, and we're dividing by the total number of values. So we're dividing by the total. So each individual box divided by the total. So I'm going to need your help in filling in this table. I'm going to put them on the side because that way we don't have to flip back and forth. But from the previous page, this one was a 10, that was a 12, 12, 11, 11, 8, 8, 8. All right. And because we did the sums, but I don't have the sums with me over here, what were the sums of the bottom row? Mm-hmm. 1, 6, yeah. All right, and over here? Okay. All right, so those are the numbers from the frequency table. We're going to create a relative frequency table. And when you're doing a relative frequency table, we got to divide by the total. So all of these numbers have to be divided by 80. Every single one of them. And this is why software and programs are really nice because they don't have to do this repetitive work. But before it gets repetitive, let me show you that sometimes some of this stuff repeats. So we're not going to do it twice. Once again, this is notes. What's the difference between a regular frequency table and a relative frequency table? The relative one has the decimals or the percents. The normal one has the whole numbers, okay? All right, grab calculators. 10 divided by 80 and then times 100. 10 divided by 80. Oh my God. So 12.50%. Okay, 0.125 and then times 100. All right, so this is the decimal. Please stay focused or there's a door. And this is the percent. Are we clear? All right, next, grab your calculator. Divide 12 divided by 80. 12 divided by 80. 0 point. Like that? Okay. Can I have the percents, please? This is 15%. What is the bottom one? Percent. Thank you. All right, this one, what's the percent? All right, next one. Please stop. Uh-huh. How much? Okay. All right. And so this is the trick in your relative frequency tables is that it is going to be 100% over here. These two are going to add up to 100. These four down here, the totals are going to add up to 100. If I add these two, I'm going to get 27.5. Okay? Just like in the frequency table. The relative frequency table works the same way. All right, so now when I ask you what is the difference between a regular frequency and a relative frequency, the relative frequency is the one with decimal slash percent. Clear? But other than that, it works the same way. All right, just looking at these percents, what percent of students are 10th graders and like English? So you look at 10th graders and you look at English, and where do they meet? Right here. So percent. What percent of students like math and are 12th graders? So you know that, you're joining there. What is it? Can y'all drop the twang, please? Is it just 10 or is it something else? Thank you. What percent of students like math? I'm not asking anymore for you guys. All right. So do me a favor right now. Find the missing numbers and then create the relative frequency table. All right, all right. So now what you're going to do is make sure that your answers are correct. I'm going to go through this very quickly. That one should be a 60. 40 minus 25 should be a 15. 48 plus 25 is going to be a 73. And 27 plus 73 is going to be 100. Okay. All right. So now for the relative frequency, it just happens to work out just fine because it's out of 100. Clear? So 12 out of 100 is going to give you 12%. That doesn't mean when you make a frequency table, it's always going to be the number with a percent sign. It just happens to be the case in this example because the total is 100. 48 out of 100 is 48%. Because you get 0.48 times 100, you get 48%. I'm going to repeat this. Just because this example takes these numbers and turns them into percent, that's not always the case. This is the case because our total is 100. Okay, so please make sure that you are doing your percent calculations correctly. Okay? So a frequency table is going to have whole numbers. A relative frequency is going to have the percents. Okay. Righty. All right, a conditional frequency is when I ask you questions regarding a specific group or subgroup. What does that mean? About a specific row or a specific column. Group or subgroup is a specific row or column. So you won't be looking at the entire table, just a section of the table. So our total won't be 100. Because if I'm only considering this column, what's the total of this column? 60. See? If I'm only considering the ones that have a headache, so 27 people had a headache. 12 of them took medicine. 15 of them did not. Please learn how to read the table. If I'm working with this one, what do these people have in common? They did not take the medicine. Okay? And how many of these people are there? 40. 15 of them had a headache and 25 of them did not. So learning how to read, and the only ones we read are these rows, the two rows, and the columns. So where the information is, the other ones are just total columns, okay? So sometimes they give them to you, sometimes they don't. You can calculate those on your own. All right, probability is essentially the same thing, the percent calculation. Okay. So when they ask you what is the probability, they're asking you what is the percent of. Clear? Please try to remember that. It's nothing new or different. So what is the probability that a participant did not get a headache if they took the medicine? So you have to understand that there's a condition here. We want to know who didn't get a headache out of the ones that took the medicine. All right. So out of the ones that took the medicine is going to be these right here. You see? So which of those did not get a headache? So it's 48 out of 60. Right? This one is the 48. This one is the 60. And what's 48 divided by 60 times 100? We're sure about this? Can I get a confirm? Okay. The next one. So now I want to test you. I want you guys to test yourself. That way you pick the correct three numbers to work with. Are we clear? So in this first question, we work with the 12, 48, and 60. Okay. The next one says, what is the probability that a participant took medicine given that they did not have a headache? So which numbers are we going to be working with? No, can we just tell me if it's a row or a column? I'm not asking for the answer. I'm saying, what are the numbers? Are we working with a row or with a column? Mhm. Are we working with a row or with columns? Are we working with the participants that took medicine, these, or are we working with the ones that did not have a headache, these? Which ones are we working with? All right, so this is the thing. Conditional probability is difficult because sometimes students aren't able to decipher exactly what they're asking you, okay? What part are we saying we don't get? Well, I said participants took medicine. So that's how I chose. It says here took medicine. So that's why I'm saying, is it these? Over here it says did not have a headache. We're the ones that don't have a headache. You see how it says no headache? So that's okay, but you said you were confused and you didn't elaborate, so I wasn't sure. Well, are we going to be using the 124860 or the 482573 to answer? Which numbers are we going to be using? So, what is the probability that a participant took medicine given that they did not have a headache. So this right here is a given. All of them did not have a headache. You see that? That means you're working with the ones that did not have a headache. So out of the ones that did not have a headache, what is the probability that they took medicine? So out of those, which ones took medicine? So 48 out of 73 times 100 will give you the probability. And what is that? 68% or 69%? Like, what is this? You guys don't know how to round, you're telling me. Okay. 66%. It's a 5 followed by a 7. You do know you have the numbers in front of you, right? They're not just on the screen. Okay, that's the second time. Are we clear? I'm going to try to explain it again. And the condition is not always going to be at the end. Sometimes they put it, sometimes they put it in the beginning. What is the probability that a participant took medicine given that they did have a headache? So what do all of them have in common? Do they all take medicine or do they all have a headache? They all had a headache. So given is working like a keyword here. Yes, so we're looking for the ones that all had a headache. So once again, the ones that did have a headache, so these people right here, these 27 people, what is the probability that they took medicine? So it's going to be 12 divided by 27. The answer, round it to a whole number. 44%. Confirm? Okay. All right, they want us to calculate the joint. Basically, the joint and marginal is going to be the relative frequencies, okay? The relative frequencies. And we have the numbers up here, so please start dividing so it doesn't become a joke. Here we go. So it's going to be 12 divided, oh, all of these are divided by 100. So what did we just learn? What's 12 divided by 100? 12%. Mm-hmm. Right? 48 divided by 100 is 0.48 times 100, 48%. So they're giving us easy numbers to work with. Are we clear? That's all it is. But don't you dare think that this is always going to be the case. This is only happening because the total is 100. This is the second time that I say it on the video. For those of you wondering how we're getting these numbers, give me 1 second. So for example, it's 27 divided by 100. That gives you 0.27. And then we multiply this by 100 to turn it into a percent. And so we're back at 27%, okay? And it all happens because of this 100. If the total is different, the numbers are going to be different. All right, back to this one. Now we're using the relative frequency table. What is the probability that a participant who did not get a headache, participant with no headache, took medicine? So are we talking about all the ones that did not get a headache or all the ones that took the medicine? Exactly. This time, it's all the ones who did not get a headache out of those who took medicine. So no headache. So no headache is this right here. So what are the two numbers? Took medicine. How many took medicine? So 48% divided by 73%. Turn it into a decimal times 100. Please don't wait. I shouldn't have to wait for an answer like this. Come on. 66%. All right. Next one, listen to the question. What is the probability that a participant took medicine given that they did not have a headache? So now ask yourself, are we talking about all the ones that took medicine or all the ones that did not have a headache? Exactly. Now this time, the condition is at the end. So, and we're still dealing with this, did not have a headache and took medicine. So it's 48 out of 73. So is it the same question? Yes, but asked in different forms. And you have to be able to read the question and understand what they're asking you. All right, did I emphasize these problems that are the same question but are written differently? All right, this one, what is the probability the participant took medicine or they did have a headache? So what is this? Are we talking about everybody that took the medicine or everybody that did have a headache? Everyone that did have a headache. So that means we're talking about this row. So what is it that took the medicine? So 12% out of 27%. 40, 71%? You sure? 27 is close to 30 and half of 30 is 15. So that would be 15, not 70 something. 44%? Okay. All right, I already talked about some problems being the same, okay? Now this one. All right, students were surveyed about whether or not they have a pet or if they're allergic or not to animals. The results are shown below. Now, when you do this one, I want you to write down the two numbers that you're using and then turn it into a percent. Clear? Now, this one says, what percent of those surveyed are allergic to animals? What percent of those surveyed who are allergic to animals have a pet? So are we talking about all the ones that are allergic to animals or all the ones that have a pet? Exactly. So the total is allergic to animals. Where's allergic to animals? Row or column? It's a row, right? Allergic to animals. So those people, how many have a pet? 32 have a pet, right? All right, so 32 out of 224. Okay, so this you have to use a calculator, turn it into a decimal, and then times 100. Or heck, you can just do it all at once. And I think some calculators have a little percent symbol. You just click on it and it automatically turns it into a percent to you. Okay, so what's the percent? Can I get a confirm? Just saying, because you know he keeps on messing up the number. It happened twice. All right. Let's see if you did get today's lesson. B, C, and D on your own. Let's go. Okay, here we go. Okay. I know, but I want to make it in video. So, what percent of those surveyed who are not allergic to animals have a pet? So, no. Let's think through it so that the people listening. So, so we want all the ones who are not allergic to animals. Right here, yeah. Out of those, how many have a pet? So 213 out of 276. Okay. All right, let me look at the next one. What percent of those who have a pet are allergic to animals? So am I looking at everybody that has a pet or everybody that's allergic to animals? Hmm? No? Read it again. It's all of those that have a pet. So we're looking at everybody that owns a pet. Out of those, which ones are allergic to animals? So 32 out of 245. And what percent is that? 25? Correct? Because I heard 13 and then I heard 45, so I don't know what's going on. How is it 45? How's 32 out of 245? Please don't just talk. Add to the class. If not, just keep it quiet. All right. What percent of those who have a pet or are not allergic to animals? So where are you focusing? Where is the whole group? We're looking at everybody that has a pet. Out of those who have a pet, how many of those are allergic to animals? Let's see. So we're still looking at the pink. 245, what are you talking about? 245% doesn't exist. Oh, how many have a pet? 245? And how many of those 245 are not allergic to animals? 213? So it should be 213 over 245. Sorry, I misunderstood what you were saying. And what is that? 87%. But guess what? This is 13%, right? This one's 87%. And this is 100%. You see? When we're doing relative frequency, you take the whole table and you focus it in that subgroup, okay? All right, good, good, good. Some of you saw it. The rest of you guys are like, I don't know what you're talking about. Um, all right, we'll leave this one for tomorrow.